Hey everyone, I hope you're all staying safe and healthy with the whole global pandemic going on. Hopefully you're staying home, staying away from other people, and spending as much time on your phones as you do normally during class. So today I'm going to go through lesson 6-1. A-Day classes, I know this is a bit of a review for you, but I figured after 2 weeks of no school, a review wouldn't be a terrible idea anyway. So in 6-1, we're looking at some exponent rules that you guys should have learned in middle school. So this should be mostly a review. So the first one, power of a power, is when you have a number raised to a power and that whole quantity is raised to another power. In that case, you're going to multiply the two exponents together. So in this example that you see here, I have 2 to the third power raised to the second power, which would mean it's 2 to the 3 times 2 power, or 2 to the 6th power. You can plug that into your calculator to see that the two quantities are exactly the same. The next one is the power of a product. So that's when I have two different numbers being multiplied together, and that whole quantity is being raised to a power. In this case, each number that is being multiplied together can get individually raised to that power. So 2 times 3 to the second power is equal to 2 to the second power times 3 to the second power. The next one, the product of powers, is when you have the same base number, that's the big number, and it's raised to two different powers and it's being multiplied together. So if we have 2 to the third power times 2 to the second power, we're going to add those powers together. So it's 2 to the 3 plus 2 power, or 2 to the 5th power. Then the quotient of powers, that's when we have the same base number raised to a power divided by that same base number raised to a different power. In that case, we're going to subtract the exponents. So if I have 2 to the 5th power divided by 2 to the third power, that's going to be equal to 2 to the second power. Now in your packet that you hopefully downloaded, you'll see that there is a question that says, how do the properties of exponents help solve equations with rational exponents? I'm not going to have you answer that question just yet, because we're going to see how this works in our next example. So here we are with example 1, and we have two stamps, stamp A and stamp B. They have the same area. Sorry, there's a typo in there, so it's not the same R. Their side lengths are expressed differently. Both stamps are square. So how can we show that the square root of 2 is the same as 2 to the 1/2 power? So first thing we need to do is we need to remember our area formula. So what is the area formula? Area equals the length times the width when we're dealing with squares and rectangles. What we know about squares is that the length and the width are the same. So for stamp A, to find the area, we're going to do the square root of 2 times the square root of 2, the length times the width. Let's plug this into our Desmos Scientific Calculator. So I'm going to put in the square root of 2 multiplied by the square root of 2. And you'll see that the square root of 2 times the square root of 2 equals 2. And the units we're using are centimeters squared. All right, for the area of stamp B, we're going to do the length, 2 to the 1/2 power centimeters, times the width, 2 to the 1/2 power centimeters. Now we're multiplying the same base number with exponents together. So that's going to be our product of powers property. So we are going to add the powers together. So we have 2 to the 1/2 plus 1/2 power, which gives us 2 to the 1 whole power, which is equal to just 2. And again, our units are centimeters squared. So when we did our length and width of the square root of 2 and our length and width of 2 to the 1/2 power, we got the same area for both squares. So do you think from this we can conclude that the square root of 2 is equal to 2 to the 1/2 power? So now let's look at part B. Stamp C has a different side length. Can you express the cubed root of 5 squared using a rational exponent? When we're talking about a rational exponent, what we're talking about is an exponent that is a fraction. So there's a certain structure that we use to figure out this fraction exponent. The number on the outside of the radical sign is going to be the denominator of the fraction exponent. The number or the exponent on the inside of the radical is going to be the numerator of our fraction exponent. The big number inside the radical is our base number. That's going to be the big number for our exponent as well. So using these rules, we can write 5 as our base, and then we're going to have 3 as our denominator, and 2 as our numerator. So the cubed root of 5 squared is equal to 5 to the 2/3 power. Let's look at our try it problem next. So our try it problem is another one where we're rewriting a radical as a rational exponent. So we have the cubed root of 2. So we know that 2 is going to be our base, and we know that 3 is going to be the denominator of our fraction exponent. But it looks like we're missing something. What are we missing here that we didn't have in part B of our example? That's right, our numerator. What do you think the numerator is if we don't have a number as our exponent inside the radical symbol? If you look back at the example, you'll see that the square root of 2 has no numerator and no denominator to be seen, but we still found it was equal to 2 to the 1/2 power. So if there is no exponent in the radical, then the numerator of our rational exponent or our fraction exponent is going to be 1. So this would be 2 to the 1/3 power. All right, moving on to the practice problems on the next page. We want to practice what we just did in our example and our try it problem, and that is to write the radical using exponents. Go ahead and give these a try. I think you guys can do this. In problems 15 and 16, it's a little bit of a different type of problem. In these, we have a missing value in our exponent that we have to find. That missing value is represented by x. In these types of problems, we need a common base, meaning a common bigger number, to use all of our exponent properties that we went over on the previous pages. In problem 15, because 4 is the smaller number, we're going to use that as our base. And we have to figure out 4 to what power equals 64. So I'm going to write out my 4 exponents. So 4 to the first power is 4, because any number to the first power is itself. 4 to the second power is 4 times 4, which is 16. 4 to the third power is 16 times 4, which is 64. So we see that 4 to the third power equals 64. So to get our common base of 4, we can plug 4 to the third power in place of 64. So we have 4 to the third power to the x plus 1 power is equal to 4 to the x plus 7 power. Now, if we remember our exponent rules, when we do a power to a power, we can multiply the exponents together. So I can take the bases out now and just concentrate on my exponents. So using my power of a power rule, I can write 3 times x plus 1 is equal to x plus 7. Now this is just a regular equation like we've been solving all year. So let's review the steps that we would take to solve this equation. So my first step is going to be to distribute that 3 to the numbers inside the parentheses. So 3 times x and 3 times 1. 3 times x equals 3x, 3 times 1 equals 3, and that's still equal to x plus 7. Now I'm going to want to get my non-x's together, my constants together, so I'm going to subtract 3 from each side of the equation. So I get 3x equals x plus 7 minus 3 is 4. Now I want to get the x's together, so I'm going to subtract x from each side. So I get 2x equals 4. Finish this off by dividing each side by 2. And I'm going to get that x equals 2. Now let's take a look at problem number 16. It's the same situation where we need to find a common base number. This time we'll use 2 as our common base because it's the smaller number. So we have to figure out 2 to what power equals 16. So I'm going to write out my 2 exponents. 2 to the first power equals 2. 2 times 2, 2 to the second power, is 4. 4 times 2, 2 to the third power, equals 8. And 8 times 2, 2 to the fourth power, equals 16. So we found that 16 is equal to 2 to the fourth power. So we can plug 2 to the fourth power in place of 16. So we get 2 to the fourth power to the x minus 3 power equals 2 to the x minus 6 power. We're going to use our power of a power rule again and multiply the exponents on the left side of the equal sign. So we get 4 times x minus 3 equals x minus 6. Again, we took those bases out because we don't need them anymore. So I'm going to let you guys go ahead and solve this on your own. I hope you enjoyed Lesson 6-1. Stay tuned for Lesson 6-2.